Yeah, I was going for this.
25.
Which is worth it. What's 50 minus 28 then? You're taking 3 more away, right? 50 minus 25 is 25, so 50 minus 28 takes 3 more away. 22. No, you're not in math class. I'm Ethan. Are you yawning? Who was it? Hopefully, everybody is back. That's all they missed. I think we caught him up.
What? What does that have to do with the screen going out?
All right. This is the internet. This is what the internet is like. These are YouTube comments, guys. On the worst of the internet. Subtraction. 32 minus, what are we at, 54? It's just 30 plus 2 minus 50 minus 4. What's 30 minus 50? Negative 20. We're asking the distance between them, right? And it's negative. Because we're going from 50 to 30. That's to the left. What's negative 4 plus 2? Negative 2. Could you do plus 2 minus 4? Sure, but that might be harder. Negative 4 plus 2 is negative 2, right? You know it's going to be negative. That's the bigger one. Ta-da! That's it. Let's do another one. Even! Wait, be patient. I'm not ready yet. Okay. Even! Give me a number. 72. Awesome. Jace. Nice.
You what?
I don't know. I don't have a good one for that. Okay. I stand by my statement. Ethan poo-poo head. All right. 72 minus 69. How would you do it? Okay. You're going to shift it. Done. How else might you do it? You ever heard about counting up? Right? 69. Nice. The distance between them? Well, one way to figure out the distance would be to count the distance. Right? 1 to get to 72 to get 72, 3 must be the answer. You can also count backwards. 72 minus 69, but again, we're going the wrong direction, right? This says start on 69. What about... What's 70 minus 60? What's 10 minus 9? Add 2. Want to see another way? Let's make it nicer. Give me a number. 102. I didn't even call on her. She was so eager. She wants to do subtraction. She wants to learn. If you let kids have choice, they'll choose to do nothing. Yeah, if your class sucks. All right, 102 minus what? Come on! Be brave. Even number. 69. All right, he was gonna say it. All right, so we can borrow, right? What if we don't? What if we don't say we did? What's 2 minus 9? Think about that. It's gonna be negative, right? Thank you. What's 0 minus 6? Remember, this is a 0 that stands for the number of tens. So we have 0 minus 60. What's that? D. Very good. Right? Because that's what it stands for. What's 100 minus nothing? Positive, right? What's 100 minus 60? 40 minus 7? Close. Oh, wait. Nope. You're right. I'm wrong. Numbers are hard. 33. Wait, you don't have to borrow? You can just... Yeah, you can. You know why? Because this is 100 plus 2 minus 60 minus 9. That's negative 7. Do you see it? Do you see it now, Mr. Krabs? Why didn't they teach you that? Why did they make you borrow? Oh my God, you can't do that in your head. Right? Borrowing sucks. -7 minus 60, 100. 100 minus 60 is 40. In fact, you can go left to right. 100 minus 60 minus 7. I think one of the reasons they don't teach you this is because, one, your teachers only know one way to do it, because they were taught by a teacher that only knew one way to do it, who was taught by a teacher who only knew one way to do it, who was taught by a teacher that knew multiple ways of doing it, but only wanted to teach one, because getting the answer quickly is what's important, because we're on a time test, kids. We don't have time to think. Accuracy is important because there were no calculators. Your job is to be right, not to think of a new way to do it. Or to be, you know, clever. I also think they didn't teach this because you didn't know about negative numbers. And negative numbers are hard. Oh my God. No, they're not. This is the same as -7 plus -60 plus 100. -67 and 100. Oops, sorry, that's 9. That's what it should be, the original problem. Plus 2. Wait a minute, hold on. This says 7, this says 100. This was 102, this was 69. Wait a minute. What? Why do we have 107 here when this should be clearly a 9, and then there should be a 2 there? Why? It worked out. Trust no one. Why did it work out? Subtraction is what? What would you like to shift this to? Means that's going to be what? Right? That's what happened. It's all baked in. It's not which method you want to use, it's that all the methods are really the same. And of course they are, because they get you the same answer. Just different ways of looking at it. Again, the Jewish people have an expression called turning the gemstone, where they take a gemstone, not like this is a sphere, and they turn it in the light. And every little bit that they turn it, the light refracts differently and produces a new color, a new spectrum. One thing with a million different perspectives. And the more perspectives, the more beautiful it is. That is mathematics. We take one problem, and we look at it in lots of different ways. Or we could do, 100 problems and half the answers in the back of the book, and the other half, doesn't matter if you get right or wrong, because the teacher's going around and checking for completion. This is learning. Everybody loves it. That's subtraction, kids. Any order you want, as long as you keep the signs with the numbers. You can shift things around as long as you, preserve the distance, because that's what subtraction is. Right? If you're moving one to the right 2, you need to move the other to the right 2. Math doesn't have to be hard. And the people that are good at it are not the ones that have things memorized, because eventually there's going to be a number they don't have memorized. Right? 12 times 12, 144. I'm the smart kid. I got all the ice cream. Then you ask them 12 times 13, and they sit there like, Some of them will be like, oh, I know he asked that. Just 12 more. But if I waited a day and asked 12 times 13, they'd all scratch their heads. You spend all this time learning math, and you come out knowing nothing. And you feel dumb, because I can't memorize all that. Dude, it's infinite. Of course you can't memorize all of it. We have expectations that are unreachable. If you want to be good at math, you just need to understand it. I don't know. That's why I spend time doing this. Geometry, right? Meh. I don't know. Could be anytime. I asked the question. First quarter midterm. Awesome. Today. No wonder kids are freaking out. I didn't do my portfolio review. Oh my god, I had 3 weeks to work and I did nothing. Oh my god. This can be the easiest class you ever take. And not just that it's easy, but also probably the most beneficial. You'll learn more in here than you ever have, if you take advantage of it. And you should. Don't just be like, oh, I had the chance to learn all this great stuff and I just chose not to. That makes you a dummy. By definition, sorry, it's not me calling you names, it's just the definition of a dummy. I would rather not know. Ignorance is bliss. You have no excuse. I've removed them all. It's on you. The effort you put into this class will be the results you get out, and that's not BSing you like everybody else does, right? You work real hard and you study the night before and you try to memorize all that stuff and you still get an F, right? In here, that's just not the case. Which, to me, makes sense. I think everybody should go read Olivia Barron's post about her experience in school. How she feels about it. Good. Haley's is also really good. Good read. The beginning of Olivia starts with, I like how in this class we can do whatever we want. We can go to sleep, we can be on our phones, we can do whatever. And I imagine another teacher reading this and going, what? This guy's nuts. Some new age bullcrap. And the next sentence talks about, and I think that's a good thing, because when I'm not allowed to do those things, I do them anyway. The teacher thinks I'm learning because my eyes are on her. You ever heard that expression? Right? Eyes on me. All that does is compliance. I know they're watching. And that's how I know they're learning. BS. How many people are looking at me right now and not thinking about what I'm saying? Yep, go ahead, Annie. Right? Take advantage of this. People in here. I know online learning's not the best, and it's like your internet can suck and it can drop out, or I could stop the stream randomly. I don't want to have to take 2 days to cover subtraction anymore. I want to cover it once. And if you're here, great. And if you're not here, awesome. I covered it. Good to go. Videos are up on YouTube. You can always watch them. They're labeled by date and time. Today's video is called, let's see, 9/18/20, playing with subtraction and maybe division. We didn't have time for division today. We'll cover that next week. Go watch it if you missed it. Or if you need to write a blog post and you forgot what we did, go check it out. I want you to write about addition, subtraction, or multiplication, your choice. You can do more. I would encourage you to do more. Explain different methods. Explain why they work. Why can we add the same and subtract the same from both numbers and have them be the same after we subtract them, right? Why is 20 minus 7 the same thing as 23 minus 10? Explain that. What happens when we borrow a 1? What's really going on here? Do we have to borrow, and why not? Understand this. Give me a number, Jace. Give me a number, Ethan. 44. Y'all got played. How would you solve a problem like Maria? Uh-oh. You know what I would do? You know what 11 squared is? What? Not 11 plus 11. 11 times 11. Remember when we joked earlier about 12 times 12? Oh, I know that. 12 times 13, I don't. What's 11 times 10? 110. Add 11, 121, yep. What's 121 times 4? I would do this one, 484 times 10, and then divide it by 2, and then add 484 to it. Yep. Ooh, this one's interesting. See you guys later. Kobe, what's up? Yo.
Yo.
Hey man, guess what?
What?
I got another accident.
Hey Josh, this is not funny.
I know, it was
it's
my fault.
expensive.
Yeah,
And it's
on my
also
part.
really bad because other people get injured and hurt.
I
And
know.
on top of that, so can you.
You're in the title of
But
first driver.
no, know where Fat Boys is?
Poor Fat Boy
And then
is.
a guy talked to me too, because he crashed into the car in front of him also. So I was the last one in the line.
That's
Like,
Josh, I'm concerned. Winter is approaching.
I'm drive carefully.
My best
so
friend
far.
died in a car accident. Please do not do this to me. I have lost so many students over the year to not just car accidents but other things, but especially car accidents.
Yeah, but I was down by Fat Boys in this car. This oversized truck decided it would be a good idea to stop in the middle of the road. So there's like 6 cars ahead of me. They all abruptly stopped. So 2 of them ahead of me got in the crash. I only like dinged his car, but my car was just fell apart.
Dispossession.
What is this?
Oh yeah.
Beautiful. Where'd you get it?
I
Oh.
spent $90 on it the other day, so I got
Wait, on that book?
My car fixed.
Oh wow.
Stop driving.
That's probably a good idea.
My brakes are broken also.
You're not fast.
No, it was just because the brakes are broken. So when I brake, that's
Yeah, doing the 10 and then adding one group of that, pretty smart. If you need to do a portfolio step 105 to 325 is what I'm available for today. I do not want to make a habit of having to go on Fridays and do all this stuff. This is the time where I'm supposed to get ready to do all this crap and put this stuff together. So if you miss portfolio review, make sure you're not doing that from now on. Tuesdays, Wednesdays, and Thursdays is when I have days. Sign up, get it done. Thank you. Also, did everybody get a syllabus in here?
Yeah.
Syllabus? Okay.
I don't think I did.
Yeah, I
You
got
passed
the
it.
list.
Okay, I know some of you did, some of you didn't. I still got leftovers, so. No, I do, but I don't know where it is. I don't know. Might be at home when I transferred everything over. Hi, Steven. All right, so Steven's here, Adam is here, Nevaeh's here. Anybody seen Cliff? All right, Max, Rowan, Josh. Looking for Carter, Maddie. We got Skylar. Geneva is not here yet. Lindsay is not here yet. Those of you that had portfolio reviews,
Yes.
did you feel like it was beneficial? Or a waste of time? Who did portfolio reviews? You didn't yet, right? You didn't yet. Right. Josh, we didn't meet yesterday. Did we meet yesterday, Tickler? We did not. So, this is my class of most people that did not. So, the only person that did was Rowan.
I
No.
signed up for a time, but
Hey,
Oh, I
Geneva.
couldn't come in yesterday.
Geneva met yesterday. It was my other half of the class that met a lot.
Oh, I didn't. My Wi-Fi was not.
All right, so
Data.
today, people that are in the chat, if you were here in person yesterday, you can leave after I tell you this. Your assignment, and it's an assignment that you get to choose optional. I want you to write for your portfolio either about addition, subtraction, or multiplication, explaining different methods and why they work. Okay, not just showing different ways of doing it. Again, make up your own problem. Go into why it works, use diagrams, pictures, whatever. Really show that you understand how this stuff works. Okay? If you were here yesterday and you were watching the stream or you're here in person, get on out once you've checked in. So Skylar, you're good. Steven, you're good. Carter, if you were here yesterday, I don't remember if you were, Carter, then you're good. Geneva, same thing. Okay? For those of you that were not here yesterday, which sounds like almost everybody, we're going to be talking about what we did yesterday. I don't want to make a habit of having to go over something twice because you guys didn't watch the day before. I understand sometimes crap can happen, and that's cool, which is why I have the videos up on YouTube so you can go back and watch them. And missing out on these classes is going to prevent you from being able to complete stuff in your portfolio, okay? When we do the thing. YouTube is really great because you can pause, fast forward, rewind. Please take advantage of that. But today we're going to talk about subtraction for you. Next week we'll get into division. I'm going to try and do it today, but I don't think we're going to be able to do it since so many people are gone. So, what is subtraction? What do you think subtraction is? Taking it away. All right, hi Maddie, I see you. All right, so looks like the only people I'm missing are Lindsay and Cliff. Taking something away. What's another way to think of subtraction? You've been doing it since you were like first grade, right? Yeah. The difference between them, sure, yeah. The remainder, more or less, yeah. How far are 7 and 5 apart? Try again. 2. Now, 7 and 5 aren't too bad. But if I give you bigger numbers, what would you have to do to figure out how far they are apart? Subtract them, right? Now notice we started on 5 and went to 7, the distance was 2. And the way I wrote the expression or the equation is I had the 5 second, right? Even though we started on 5. That's kind of weird. This is asking what's the distance between 5 and 7? 2. Now the distance between 5 and 7, the distance between 7 and 5 is actually the same because distance does not care about direction. However, subtraction goes a little bit further than that. It's not just distance, it's also the direction that you're going between them. Because 5 minus 7 is negative 2. Again, the second number is where we start, right? And the first number is where we end up. So direction matters. But the distance is the same. So that means, if you don't like 5 minus 7, hard question, you can change it to 7 minus 5. And as long as you know you've changed direction, you know you've changed sign, right? When I say 5 minus 7, why is it difficult? 7 is bigger. You know the answer is going to be negative, right? Great. You got that? The answer is negative. Switch it around. What's 7 minus 5? But you said the answer is negative, so the real answer is... That's it. You can flip them around. You're going to get a different answer. They're not the same. Because the direction will be different. But as long as you know the direction to begin with, and most of you do, because you can recognize a hard problem when you see it, you can remember, okay, answer is negative, it's 7 minus 5, it's 2, so negative 2. That's it. That's all subtraction is distance. This is going to be really important as we go further. So, how would you solve a problem like Maria? What would you do? Lots of different ways. You can tell me the boring way if you want. Talk about as many ways as possible. Yeah? It's okay. How'd you figure that out? Whoa, check this out. He did 1 minus 7. Now, elementary school teacher's gonna go, no, you can't do that, you gotta borrow, right? And that's true, you can. But he did 1 minus 7, you said 6, but it's gonna be negative or positive? Negative, right? Obviously, right? 1 minus 7, it's gonna be negative. Distance is 6, so negative 6. And then what's 20 minus nothing? 20 minus nothing is 20. You don't have to borrow. In fact, you can do it from left to right. What's 20 minus nothing? 20. What's 1 minus 7? Negative 6. Add them together. 14. Lily thinks of it like this. 7 times 3 minus 7 times 1. And because they're both talking about apples here, not apples and oranges. They're both 7s, right? 3 groups of 7 minus 1 groups of 7 is 2 groups of 7. 14. Right? Can't do that for all subtraction problems, but because these are both multiples of 7, you can, right? So yeah, you don't have to borrow. Gosh, that was really well done. It's just 20 minus nothing, so 20, and then 1 minus 7 is negative 6. Put them together, 14. When I say put them together, I mean addition, right? Right? I missed this earlier.
Adam.
Right? So what's happening here? When I say put them together, I'm saying this. We're adding a negative 6. It's the same thing, right? Because a negative times a positive and a negative... no. Okay, stop. You're thinking too hard. When you add, you can do it in any order, right? When you subtract, you can't, right? Because if I flip the order, it changes the answer. But when I add, I can do it in any order. So if I think of this as addition, I can do it in any order. Doesn't matter. You can go from left to right, right to left, doesn't matter. As long as you know that the sign stays with the number. See how 6 was negative? See how it's still negative? See how it's still negative? As long as you keep the sign with the number, you're fine. PEMDAS is a lie. You can add and subtract in any order. As long as you keep the signs together. See up here how we didn't keep the sign together? It was minus 5 and now it's a positive 5, right? That's why we get a different answer. But if you keep the signs together, you're fine. 7 minus 5 is 2. And then negative 5 plus 7. Again, positive 7, negative 5, also 2. And this is useful. Obviously 2, right? Whoops, sorry. Zoom out. What's another way you might solve this? 21 minus 7. Imagine, number line, 2 numbers on it, okay? You don't know what they are, it doesn't matter. They're this far apart. Remember, subtraction is what? Hello? Distance, right, between them. Now what happens if I shift both these over 5? Did the distance change? So the problem didn't change. Just a different way of looking at it, right? Now I'm looking at it over here. What if I have 2 numbers and I move them over the left 2? As long as I move them both, does the distance change? True or false? Hi, Lindsay. True. Adam shook his head at first, though. Why do you think it wasn't true? Numbers are different, right?
Yeah.
How are they different, though? Yeah, I did, didn't I? I took my numbers and I shifted them one over to the left. Does the distance change? Then subtraction doesn't change. Now, can I do that with addition? No way, right? I mean, come on, right? 21 plus 7 is not the same as 20 plus 6. Can't be. Right? These are 2 smaller numbers. Those are 2 bigger numbers. They can never be the same when you add them up. Because addition isn't about the distance, right? The distance between 21 and 7 is the same as the distance between 20 and 6. But the amount you'd have when you put them together would be different, right? But distance stays the same. Now this is helpful, because I can do 20 minus 6 way easier than 21 minus 7. Now maybe that's too easy for you. Maybe you need something more drastic. Rowan, give me a number. 12? All right, I won't write it down yet. Nevaeh, give me a number. 7. Isn't that the same as 15 minus 10? How do I know that? Move this one up 3, move this one up 3. 5. Maybe you'd like to go down. Maybe you do 10 minus 5. Move them both down 2. Give me bigger numbers. Go. 36 minus 69. Nice. Let's use Josh's method. Sure, we can borrow. In fact, I'll show that first, right? That's a 2 now. That's a 16. What's going on here? That 3 stands for 30, right? Now it's 20. I'm rethinking of 36 as 20 plus 10 plus 6. Why am I doing that? That way I can subtract 9, right? 16 minus 9, 7. You can count up. That's another way to do subtraction, right? I'm on 9. Here's 16, I want to know the distance. Well, one way to figure out the distance between them is to literally count. 1 to get to 10, and then 6 more to get to 16. So 7 is the distance. Counting up works. I like that. So I know it's 7. And then I've got 20 minus 60. What's 20 minus 60? Oh, no. Can't do that. Got to borrow. Oh, no. There's nothing to borrow. Let's use Josh's method. What's 20 minus 60? It's got to be negative. The distance between 20 and 60 is 40, so negative 40. That's a positive 7. Using Josh's method the whole time is this. 36 minus 69. Let's go left to right. What's 30 minus 60? Negative 30. What's 6 minus 9? Left to right is actually easier. Why don't they teach you this? How long have you been doing subtraction? A long time. And they didn't think, okay, today, kids, instead of today, we're going to memorize 10 minus 1, 10 minus 2, right? Repeat after me. What is subtraction? Taking away. That's helpful. Now I think about it in a whole different way. It's true, but it's not helpful, right? They couldn't have taken one day and been like, okay, kids, today we're going to do something fun. We're actually going to understand what subtraction is, and that it's not hard. I don't know. You could borrow, or you could not. And you would just get the right answer. Now, one of the reasons they don't teach you this, I think, is because their teacher didn't know how to do that. And their teacher didn't know how to do that. And then their teacher did. But then they're like, wait a minute. I need to get them ready for this test. I need them to be fast. They don't have time to think, right? I'm going to teach them one way. Don't want to confuse them. Working in factories, there's no electricity or calculators. They need to be accurate. And this way guarantees it if they borrow and they're careful, right? And it works every time. And it requires little thinking, which is good because we don't want factory workers learning how to think. Then they might become factory owners. Can't have that. The other reason I think they don't teach you it is because you didn't know about negative numbers. Because negative numbers are something we had to reserve for 6th grade. Remember you learned about those? 7 minus 1, 6. 1 minus 7, 6. Oh, what? Oh, I guess wrong. Negative 6. And you're so confused about it, and you had to memorize negative times a negative is a positive, and positive times a positive is a positive, and positive times a negative is a negative, and negative times a positive is a... I'm learning! Right? Or you could just think about it. So negative numbers are direction. So if you take a positive number and do it 3 times, great, you've gone more positive. But if you take a positive number and undo it 3 times, guess what? You went to the left. So your answer is going to be negative. That's why a positive times a negative is a negative. Duh. Take a negative number, times it by a positive number. Great, you're going to keep doing more negatives. You're going to go left. The answer is going to be negative. Take a negative number and do it negative times. Wait a minute. Negative means change direction. So if I'm going to the left because I'm negative 3 and I'm multiplying by negative 4, well, now I'm changing directions because negative 4 changes the direction. Now I'm going positive 12. It's just a matter of direction. And we spend like all 6th grade and 7th grade talking about this. And we bang our heads against the wall wondering why the kids don't get it. Doesn't make sense to them. It's just random memorization. You either know it or you don't. Ever heard that phrase in math? Yeah, ridiculous. And again, the problem with math is that it's abstract. We create it. And so when we talk about, 3 times 4 means 3 groups of 4. It doesn't really mean 3 groups of 4. It just happens to work with that metaphor, right? Groups is a metaphor for what 3 times 4 is. And eventually, when math gets more abstract, the metaphor breaks down, right? You guys learned about the atom?
Atom.
Right? And it's like this thing, and there's like a bunch of swirly stuff, right? And you have like this picture, right? Going on. And that's a great picture because it helps you visualize the atom and learn about it. But the problem is that's not actually a
atom.
It's a model. Just a model. That's not really what atoms look like, and that's not how they function. But it works like 99% of the time until you get really specific, and then you have to think of a different model to understand it. This is not really what's going on, but it works. It's approximation, right? Same thing with 3 times 4 being 3 groups of 4. It works until you have negative 3 groups of 4. How do you have negative 3 groups? You see what I'm saying? And when we teach you, this is what it is, and then we say, wait, it's not. That doesn't make sense. You're like, okay, this is made up. This is bullshit, right? No wonder negative numbers seem so weird. They break everything you know. We put you in this tiny box and tell you this is all there is. Instead of, hey, we're putting you in a tiny box. This is not all there is. This might help you understand it, right? But we tell you this is all it is. And then when it breaks open, you go, oh my God, I'm not a math person. So let's talk about more subtraction. Give me another number, Max. 52. Interesting choice. Josh, give me a number. 27. How do you want to solve a problem like Maria? You want to borrow, use Josh's method, you want to shift things around, what do you want to do? Yeah. Adam, what's the answer?
Adam.
25.
That's a lot easier. 52 minus 27, hard. 50 minus 25, nice. They're the same question. Oh my God. If you had known this, think of all the ice cream you would have got from the time test. Which freaks me out, right? Their whole goal is to get you to do these time tests, right? But they can't teach you this because it would take time to think. But once you know it, it's actually faster. And it's not even a trick. It's just being smart. I know they're the same because it's distance what we're talking about here. They could have taken one day, I think. Right? One day. One day. That's what I'm doing, at least. Because I got to get to geometry eventually. What's another way we could do this? 52 minus 27. What about 50 plus 2 minus 20? Now remember, that's a negative 27. If you have a bunch of money and I want to take $27 from you, of course I do, I could take 27 all at once, or I could take 20 and then 7 after, right? So I'm taking 20 and then 7 after. They're both negative, right? I'm not going to give you 7. I wouldn't do that. What's 50 minus 20? 2 and 7. The distance between them is 5. Is the answer going to be negative or positive? If you really want to be pedantic, you could be like, look, 50 minus 20. And let's do let's do positive 2 minus 2 minus 5, right? I'm reimagining that 7, right? Gone. 25. Oh yeah, pizza for book reports and stickers. Yeah, they did ice cream. Except here's the thing, most of them didn't get any. This is trauma. I mean, this is education. Again, psychological trauma is a valid form of education in some schools. Most schools. Because why? You'll never forget. Hey, it works! Right? Does it? How come they hate math class? I don't know why. Let's talk about another possible way of thinking about this. Let's do, you said 52 minus 27? Was that right? Which is obviously 25 now, right? I mean, come on, shifting. We love it, we love it, we love it. Let's talk about borrowing again. 40, 12. What's 40 minus 2? Very good. 40 minus 20. I misspoke. Very good. 40 minus 20 is 20. What's 12 minus 7? You want to count up, right? 8, 9, 10, 11, 12, 5, right? Or you can count up 3 to get to 10, 2 more to get to 12, right? So 5. Josh's method. Don't borrow. 50 minus 20, 30. 2 minus 7. Well, it's 5. It's negative. 25. Subtraction is not associative. You can't switch the order. We talked about this, right? 7 minus 5 is 2, but 5 minus 7 is negative 2. You can flip them if you want. Just change the sign if you flipped them, right? Because the direction will change. We're starting on 5 and going to 7. That's 2. We start on 7, go to 5. That's negative 2. How would you solve a problem like Maria? What would you want to do first? So these two first? Okay. How would you do that? Well, but negative, right? How'd you figure out it was 12? Say it again. Oh, okay. So you counted up 5, 2 more to get to 7, and 10 more to get to 30, right? He counted up, and then he realized the answer had to be negative. Okay, cool. Now what'd you do? $90 and then subtract 2 more. So what he's doing is literally this, right? Now again, that minus 12 is minus 10, then minus 2 more. Don't goof that and think it's a plus, right? Now what about this? Is this the same problem? Has to be, right? Because this is 100 minus 12, and this is 100 minus what we know is 12, right? It has to be the same. A lot of you will write this. Is this the same problem? You can do 102 and subtract 10 and you get 92. Uh-oh. Uh-oh. Right? We're taking away 12, so we're taking away 10, taking away 2 later. So check it out. We just learned about the distributive property. When there's a negative outside the parentheses, it applies to both numbers. It applies to both numbers. We're subtracting 12 is what we're doing here. In other words, we're subtracting 10 and subtracting 2. With letters, this is what that looks like. That A is just a minus sign. That minus sign stands for a negative 1, right? From before. So we're subtracting a number. Well, that's the same as subtracting the first number and subtracting the second number, right? So if I have negative 1 times 2 plus 3, we're subtracting 5 here, right? That's what's happening. Subtracting 2, whoops, subtracting 3 is what's happening. Negative 1 times negative 2, or 2 is negative 2. Negative 1 times 3 is negative 3. It's all the same. And that number in front doesn't have to be a 1. It could be anything. It could be like a 12, right? 24. Same idea. You can think of it as we're adding 24 and 36 together. You can think of it as we're doing 12 times 5. Any of that. It's all the same. But it's not because someone told you this is the distributive property and this is how it works. It's magic. It just does. And if you don't know it, you don't know it. And if you do know it, you do know it. And you're going to get ice cream. And the other kids are going to get an F. It's because if it weren't, it wouldn't make sense. We're subtracting a number. If I subtract 2 and if I subtract 5, it's the same thing as subtracting 2 and subtracting 3. See how it naturally distributes? I want to do 12 times 5. Well, that's the same thing as 12 times 2 plus 12 times 3. Same idea. How you think about it, how you break it down. And the more you think about math and the different ways you think about it, the better understanding you're going to have. And it's going to be easy. The kids in class are really good at it. Like my friend that I told you earlier died in high school in a car accident. Really great at math. I thought he was just able to carry numbers in his head and do all this crazy stuff, right? Where he had a trick. He didn't. He just knew how to think about it. But instead of listening to the teacher, he sat there on his phone. When he was bored with his phone, he'd sit there and think about different ways to do math. I think what I want to do in the coming weeks is get you guys some notebooks. I didn't want to do this initially because I knew I'd scare people and set up a precedent. You gotta be copying down stuff in class. Can you imagine, right? Copy that down so I can look at it later. First of all, you're never gonna look at it later, right? Let's be honest. How often do you guys go back and look at your notes? Be honest. Some of you might, but mostly right before the test, right? The rest of you never gonna look at them. So you didn't learn in class because you're too busy doing this. You couldn't have time to think, right? And then you don't look at them. What's the point, right? I don't know, but yet this is how we do school. So I didn't want to give you notebooks right away, but I think I want to get you some, just so you can play with math. So what I have here, this is my dad's old binder. So it's just me playing with math and experimenting with different ways to do it. That's how I come up with these lessons. Ooh, yeah, letters. This is something we're gonna get to later in the year. I'm just playing with stuff. Messing with things, checking out patterns, seeing if they hold. Learning about subtraction, different ways of doing it. Lily had a problem the other night. Absolute value was really bizarre. I was working with that. And again, it doesn't have to be like Einstein level math. I'm doing 21 minus 7 here. I mean, this is the inspiration for yesterday's lesson. Talk about division. Little spoiler. Check this out. I learned this last night. Again, I learned this as a math teacher. You know how you can do like 4 times 6 and 2 times 6, and that means you have 6 groups of 6, right? Because 4 groups, 2 groups, we're talking about apples, right? Not apples to oranges, so that's totally valid. Check this out. Multiplication and division are just 2 sides of the same coin, right? Using the same logic. There should be a connection here. We're adding, right? See how we added these together and we got 6? Nope.
Adam.
There we go. So wouldn't you think that this would be true? Adding, right? If it was subtraction, we'd subtract them. In fact, we can investigate subtraction. Is this true? And is it always true? 40 minus divided by 4? Let's check it out. What's 100 divided by 4?
25.
What's 60 divided by 4? Think on a clock. What's a quarter of 60? 15. 25 plus 15? How would you do that? Would you add 10 first and then 5, or 5 first then 10? 10 first, so 35, add 5 more, 40. That checks out. Right? 16 divided by 4 times 10. 40. 25 minus 15, what would you do? Minus 5 and subtract 10, so minus 5 is 20, minus 10 is 10. 4 divided by 4 is 1 times 10 would get you 10, right? It works. Is that weird to you? Because this was bizarre to me. Anybody have any idea why that works? Does it work the other way, right? And? True or false? What do you think? Will that work? And if it doesn't, why doesn't it? No, right? Doesn't. Looks like when the second numbers match, go for it. But when the first numbers match, no go. Why is that? I want you guys to think about this. Your assignment, should you choose to accept it, is to write about subtraction, multiplication, or addition, explaining what it means, how it works. Get to it. Don't be skimpy. Thoroughly explain it. Teach it. There you go, Lily. Have a great rest of your day, guys. Have a great weekend. Bye. Enjoy manga. Thanks. Be safe. Driving. Bye, man. Hello, Ann. Not talking about division today unless we have time. Buckets. What if you flippy, though? I don't know what you mean by what if you flippy.
Yeah, let's go do it. I don't want to be here. I don't think anyone wants to be alone. You don't.
Never. I hate teaching. No, I really do love my job. I don't think being here necessarily means, you know.
I need to find a job when I'm older that I don't have to deal with people because I hate.
You're right. Common denominators.
Well, if you want to work and or I need a job where I can do people don't bite their nails, they don't chew loudly, they don't sniffle. Sammy, you're asking a lot. Tuck in my pants. I don't want to shit pants under the. Oh, sure.
Hey everybody.
I decided to be there.
Let's get Tendy taken care of.
Mr. Mac,
Yo.
you have a piece of graph paper.
Oh, of course, the best paper ever invented.
Thank you.
You can have as much as you want, bud.
I'm just gonna go make copies.
Oh, okay. Well, that's a copy of a copy. You sure you want to do that? It's kind of light.
I'll try.
Okay, if you need to print me some, I can do it. Yes, I played it last night for the first
I
time.
remember it up in here now.
2 a.m. Yep, game
I was
club.
going back and forth between Minecraft and
Alright, so let's see who I see. I see Logan, I see Ann, I see Isaiah, I see Gina, I see Jordan. I do not see Troy, I do not see Maddie, I do not see I do see Isaiah. I do not see Cooper yet. Zach, don't see him yet, or Jackson or Mitchell. No Gage yet. CJ's here, Cooper's here, awesome. Don't see Olivia yet.
bathroom, like in the bathroom.
Just not in here, yep. Got a couple announcements to make, then I'm gonna let the people that are online go. Just hang out for a little bit. That's the plan. Alright. Olivia, awesome. So we're missing Mitchell, Jackson, and Zach. And Maddie and Troy. Alright, first off, if you have not done portfolio reviews with me, I'm giving you a makeup time today from 105 to 325 before grades get entered this weekend. You may use that time if you wish. It's up to you. Otherwise, it will be a 0 for your portfolio thus far. Grades are changeable over time, but guess what? It's midterms today. Time has flown by. So that's your last chance before the weekend starts. Did you all get a syllabus? Yes, no, maybe? I pass them out? Yes? Andrew, you get one? Okay. If you have it for me, that's great. Awesome. Just leave it up on the desk or something. I just want to make sure you guys got them. You what? Oh, wait, no, this one. Yeah, so today, I don't want to make a habit out of having portfolio makeups. I think the plan from now on will be A day, B day, we'll switch off weeks, which week you have to do a review. So your B day, so you would do the week after A day for portfolio reviews, so it's every other week. You can show up to the review if you want on the week that's not your week to get some feedback. That's always good. What? I have stuff coming in the mail today. Yeah, you can make it. Well, make it. Send me an email. We'll talk about it when I have a second to get everybody arranged. You pretty much it's gonna be first come first serve. Because I don't want to make another set of appointment slots. That's way too much work for me to do. So just send me an email. We'll figure it out. I'll send you guys out a link for the Google Meets, and we'll just do first come first serve probably. But anyway, I don't want to make a habit out of that. This is your only grade in this class, so if you care about your grade, do it. And if you don't care about your grade, great, awesome, neither do I. It'll be very easy to leave comments. Did not show up. Right? I don't know. What do you want me to do? You got Tuesday, Thursday, and Wednesday to do these every time we have a review. Make sure you're doing them. Second, for those of you that were here in class yesterday or were attending virtually yesterday, we're going to be talking about basically the same thing. So if you want to head on out, that's fine. If you were here yesterday and watched the whole stream, God bless you. I don't want to make a habit out of having to teach the same thing 2 days in a row because people didn't show up. I'm going to do it this last time, and then after that, I'm not going to do it anymore. Okay? If you missed a day because you were not online or whatever, and I know that happens for lots of good reasons, the videos are up on YouTube. Go catch that, fast forward, pause, etc. Your assignment, before people leave, hopefully you haven't left yet, is going to be to write about either addition, subtraction, or multiplication, and have that in your next portfolio. Your choice is to write about which one. Don't just write about, oh yeah, there's one way to do it, right? Great. Explain why that method works. Why are you allowed to move numbers around with addition? Why are you allowed to think of 45 times 37 as 40 times 37 plus 5 times 37? What might be the best way to solve this problem, right? Give me something there. Your choice, subtraction, addition, or multiplication. Today we're going to talk more about subtraction just to make sure you guys got it. But from now on, if you miss a class, go on YouTube. Or if you need to go back and learn about something so you can write about it, go back on YouTube. I label the videos by date, time, Eddie, and I also label them by subject. Sometimes I screw up because I forget to change the name in the morning because I get swamped. This typically happens on Mondays when I got to do beep beep duty at the doors. But 9/18/20 today, the title is Playing with Subtraction and Maybe Division. We'll see if we get to division. I was hoping to do division today, but we're going to make sure everybody gets subtraction. I also have a plan to get you guys some binders with paper. That's my plan. I don't know if it's going to happen. This is my dad's old binder. But I filled it up with graph paper. And as you can see, it's just me playing with math and letters at one point. Like you can see, today's lesson was in the works the other day on here. I didn't want to give you notebooks early on because then you might think it's like a regular math class where you need to be copying stuff down. And the problem with copying stuff down is, one, y'all are never going to look at it later, right? Let's be honest. And if you do, it's like the last minute before a test. Useless. And then what do you do during class? Well, you're writing stuff down. Can you think while you're doing that? Not about what's going on. You can just be like, okay, that's a T, and then... But yet this is school, right? I want you to have time to think. And so if I gave you a notebook early on, you'd be, write that down, write that down, write that down. Where's the SpongeBob quote? Where is it? Where is it? Write that down, write that down! That's you guys, right? Because you've been taught to do this, and that's how you get smart. That's how you learn. No, it's BS, right? So I didn't want to get you notebooks early on, but I think it's good to have a notebook to play around with your math. I think you need to spend way more time thinking about math than you do writing about it. Don't just, okay, I'm going to write a post. Play around with it. Find something to say first. This can take a while. And it shouldn't be pressure. It's not like I'm assigning you math homework. Like, hey, I need to mess around with some multiplication. Make sure I know how to do it and how it works. Different ways. If you want to play around with the math in class, I would encourage you to do that as well. Got graph paper sitting up there. More than welcome to grab it. Plenty of pens and markers. Help yourself. Play with your math. This math class, let's be honest, the grade is not that hard to get. You just have to go up. You have to do something. You have to show that you understand it, and you move on. There's no pressure of a test, no pressure of a final. Take advantage of that. Use this time to really just learn and relax. You can also use this time to, blow off this class and focus on all the other ones, but like, why? Now's your chance. You can actually learn this crap. Be proud of it. Instead of, look, I did a bunch of worksheets. Who cares? No one cares. All right, anyway, so let's talk about subtraction. What is subtraction? People from yesterday, you're more than welcome to chime in, make this go a little bit faster. Again, if you were here yesterday and paid attention the whole time, you're more than welcome to leave. Make sure you know your assignment is to write about addition, subtraction, or multiplication for your next post. Make sure you're bringing your A game on that, too. What is subtraction? Oh, thank you. Delivery man thinks I'm in charge. First mistake. Looks like I just got new signs, baby. AP Science live stream or something. I don't know what it is, but I'm taking it. Fine now. Hey, Jackson. Looks like I'm missing Mitchell and Zach and Gage. Class today. What is subtraction? Come on. How long have you been doing subtraction? Since when? Isn't this great? You guys are high schoolers. What is subtraction? And I don't blame you 100%. Never do. Like, good Lord. What is subtraction? How would you describe it? Take it away now, right? Red Hot Chili Peppers, you probably don't know that song. Right? Yeah. So, taking away, great. I love how they teach you that. Because it's true, it is, right? It works. Now remember, whenever we teach you something in math about what it means, we really are using a metaphor. Subtraction, a metaphor for that is taking away. Eventually, how do you take away a negative number? Right? Well, you add it, because negative times negative is positive, but why? You see what I'm saying? Everything that we do when we teach you math, we invented math, right? Is a metaphor for what it means. Taking away works when we're talking about positive numbers. It's a good metaphor. But when we get to negative, the metaphor falls apart. You guys know about the atom, right?
Adam.
Right? That thing? Well, it turns out that's not actually an atom. It's a drawing of an atom. No. It's a model. Electrons don't really go around in orbits around a nucleus. They don't. But they kind of do. And for most of the stuff with the atom, if you think of it like that, you'll get things right. Like the equations will work out, electricity will flow, right? You'll have a good understanding. But it's a metaphor. It's a model. That's not actually what an atom looks like. And when you get into really deep, like molecular stuff, using this model gets you wrong answers. But it's a really useful model to start out with. Just like taking away is a really useful model for subtraction, right? 5 minus 2. We're taking away 2 apples from the 5 apples. You get 3 apples. And then you teach them 2 minus 5, and you go, wait, what? But how do you take away more than there is? You see what I'm saying? The metaphor sort of falls apart. And then you get like 5 minus a negative 5. You see what I'm saying? The metaphor falls apart. How do you take away a negative? Right? And then like, okay, it's debt, and we're taking away your debt. Oh my God, right? Stop trying to make that metaphor work. We need to come up with something better, right? So subtraction, you're correct, is the difference between numbers. It is taking away, but it falls apart quickly, right, after you get outside of the positives. So I want to show you something else, okay? And Lily is correct. Distance. That's because she's been in my class before. She's a college student right now, going for math art degree. Very cool. How far apart are 5 and 7? 2. Boom. Awesome. Now, how far apart are 45 and 47? If I give you your numbers, it'd be more difficult to tell how far they're apart, right? Like 13 minus, or let's do 105 minus 13, right? How far are they apart? Right? You'd have to do subtraction to figure that out, right? So subtraction is distance. It's a way to tell distance. So how far is here to here? That distance is going to be 5 minus 7, which equals negative. Wait, what? Why is it? Wait, what? Why does it have to be 7 minus 5? Shouldn't distance not matter? Like, if I walk to you and you walk to me, like, shouldn't the distance be the same? So why does it have to be 7 minus 5 and not 5 minus 7? But why does that pop up if it's distant? You see what I'm saying? Direction. Negative and positive, all they are is direction. That's it. Negative times a negative is a positive. Positive, oh my God. Negative means change direction. If positive is to the right, then negative must be to the left. Now imagine in a different world where we did right to left instead of left to right. If positive was to the left, negative must be to the... It just means change direction, that's it. Think of 7. Negative 7 is just 7 in the other direction. That's it. So think about this. A positive times a negative. Why is it a negative? Because you took a positive number and you times it by a negative, which means you're changing direction, right? If you were positive before and you change direction, what are you going to be? Negative. Now if you're negative and you times it by a negative, it's a positive, right? That's what they tell you to memorize. I'm already negative and I'm times it by a negative. Remember, negative means change direction. So if I'm already negative and I times it by a negative, I'm changing direction, I'm going positive, right? It's just direction, that's it. That's all it is. And you spend like 3 years talking about this. And it's not that they didn't tell you this, it's that they didn't tell you why. And so you had to memorize this rule. You ever heard the expression, either know it or you don't? You ever hear that in math, right? You either know it or you don't. Teachers will say this. Good God. Anyway, back to the discussion. Oh, thanks, Troy. Have them watch the video later. Send them a message. They're up on YouTube with the date and the title. So direction matters. If we go this way, going from 7 to 5. Now, isn't it weird, right? Here we started on 5 and went to 7. 5 had to be the second number, right? So if we start on 7 and go to 5, what's going to be our second number? 7. 5 has to go first. It's 2, the same distance, but the direction changed. This is great news. If I ask you 5 minus 7, you might have to think for a second, right? If I ask you 7 minus 5, you have to think 2, right? 5 minus 7, hard question. 7 minus 5, easy question. Good news, they're related. If you flip them around, do you get the same answer? No. But if you flip them around, all you're doing is changing direction, right? So if I say 5 minus 7, you can think 7 minus 5, but change the direction. 2, but negative. Much easier. Subtraction is distance. How would you solve a problem like Maria? How would you do it? You can tell me any way you know. Okay? Any way you know how. How would you solve it? Ooh. Let's think about that. You would do that because that's obviously 12. Are they the same? I mean, I know you think it. What about everybody else? What do you think? Same? 21 minus 7 and 20 minus 8. Subtraction is distance, yeah? 21 and 7 are separated by this amount. How far are 20 and 8 apart? This amount. Can't be the same, can they? We're on to something here. 20 and 8. We moved inward both, didn't we? You like 20 because 20 is a nice number. What if we move to the left for both of them? Those two are the same distance, aren't they? Aren't they? See how 20 and 21 and 7 are separated? Imagine, look at me. Number line, 2 numbers on it. Who cares what they are? They're separated by this much, right? The distance is this. Now what happens if I shift them both over to the right 5? Did the distance change? What if I shift them both over to the left 2? Did the distance change? As long as I do it to both of them, the distance won't change between them, will it? Right? Think about Patrick pushing Bikini Bottom. If they also push Barack Obama, Barack Obama, my fellow Americans, right? If you push Rock Bottom the same amount as Bikini Bottom, they're the same distance apart, right? So we don't want to do 20 minus 8. We want to do 20 minus 6. See how we move 21 to 20? We move 7 to 6. Oh, that's brilliant. I learned that the other day, actually. It's okay. But do you see why it works? Because if you shift them both the same amount, the distance doesn't change. And what is subtraction? It's distance. Does this work with addition? Is 21 plus 7 the same as 20 plus 6? Are you checking in your head? Because you don't have to. 21 plus 7 is bigger than 20 plus 6. How do I know? Because 21 is bigger than 20 and 7 is bigger than 6. When you add them together, you can't just shift them over, right? Because they're going to change the amount that you put in the barrel, right? We're thinking apples. 21 apples plus 7 apples will always be bigger than less apples plus less apples, right? But when it comes to subtraction, we're thinking about how far they are apart. And they don't change as long as we shift together. There's a fun little game we can play, and we would do this if it wasn't coronavirus, where we'd hang on to like my little stick. Where's the thing? Right here. And you grab one end, and I'd grab the other, and we'd move around the room, and we'd do like a tug of war, and we'd always be the same distance apart no matter where we were. As long as I moved to the left 2 and you moved to the left 2. Right? We can't do that. We can't have fun. Sorry. Plus, there's the, like, I got sued one time because the kid got injured, and like, we don't want to. So, anyway. But the kid's alright. Like, he's reading out of 2, but like he kind of was before, you know? You try to engage that kid in class, right? So anyway, as long as you shift them both, you're fine. It has to be the same amount, right? You can't push Bikini Bottom 10 feet and move Rock Bottom 4 feet and expect them to be the same distance apart, right? You're gonna change it. The difference is 1 feet. 1 foot. Like and subscribe. I'll get a foot cam. That's what I'm gonna use that thing for. Feet cam. I got size 12s, man. I gotta make money. I'm a teacher. Okay? Real work. If I don't have a wiki feet page, I'm gonna be upset. This is the problem. See, this is why we need the feet cam.
No. Help me here.
Size 12, baby. You know what people pay for that? A lot. Quit my job, do my real passion. That's right. If you know any people that want some, send them my way, alright? Gotta pay the bills this month. Seriously. Anyway. But anyway, so subtraction is distance. So let's talk about 54 minus, I don't know, 29. How could we shift that to make it easier on our brains? Remember, it has to be the same shift for both numbers. How can we shift it? What do you really wish 29 was? So we shifted that one over to the right, so we got to shift this one over to the right. What's that?
Yeah. 25.
That's a way easier question, isn't it? But it's the same question. How far apart are those? Well, the same distance as, you know, these are the same distance as these are, right? But these are a lot easier to understand. I like it. Maybe you want to shift down. What? Oh, wow, I'm glad we solved that. Yeah, that's right, because, oh, yeah, it's normal order.
Yeah, it's...
Boo! All right. What do we shift down? Let's do 20. Actually, let's do 4. Let's do 4. So 25, and then shift down 50 minus 25. Right? Yeah, I shifted that down 4, so I shift that down 4. Oh, yeah. Makes math a lot easier. Give me a number, Lexi. Boo! I need the Patrick. Remember it was like Patrick in the background? He's boo. Mr. Krabs in the front. There's a gif. What? 21. Okay, great. Jamie, can you do better than that? Depends on what you think is better. Oh my god! That was amazing, Jamie. 1,000 points. You. A plus. Okay, calm down. Alright, 43 minus 21. 22, right? You can just do it. Right? You get a 2 there, and you get a 2 there. Well, why do you have to start from the right and not the left? Isn't this 40 minus 20? What's 40 minus 20? What's 3 minus 1? You're like, okay, but like, why? How about this? How would you solve a problem like this? Well, now we gotta do this, right? We gotta start from the right because we can't do. We gotta, and then when it's 11, and we get okay, we get minus 3. Okay, it's not 7 because 7 would be 10, and so it's 8, and then 3 minus 1, it's 18. Okay, cool. No, we're gonna use the Josh Morris method. He thought of this earlier. He didn't invent it. What if we go left to right? 4 minus 2. No! What does the 4 stand for? So close. What does the 4 stand for? Did you say 30? You said 30. 40 minus 20. What's 40 minus 20? 20. What's 1 minus 3? Negative 2, right? You know it's negative, and then you think 1 and 3 separated by 2, right? Negative 2. Done. I'm gonna do that again. Give me another 2 set of numbers. I'm gonna do 19. It's okay. 11's not a great example because it's pretty easy to do. What's 7 minus 9? Thank you. And this is 20 minus 10, yeah? What's that? No borrowing. No shame. 7 minus 9 is negative 2. 20 minus 10 is 10. 8. You don't have to borrow. Why don't your teacher show you this? I think it's because their teacher didn't know a better way to teach them, and so they just did this, and then the teacher before them didn't know any other way, so they just taught the borrowing method. And the teacher before them probably knew, but it was like, wait a minute, no, we want to make sure these guys get it accurate, and they can make mistakes this way. If they think that's a 2 minus 1 instead of a 20 minus 10, you have no negative numbers. That's too hard for people that work in factories. We need them to be accurate because there are no calculators. They wanted you to be machines, not thinkers. Nothing wrong with factory workers. Factory workers are great. The problem is that they want to make you a factory worker that can't become a factory owner. As soon as you learn to think, then you can challenge the status quo. So you can just go. 7 minus 9, negative 2. 20 minus 10, 10. 10 minus 2, 8. Done. Way easier. Give me some big numbers. Let's go. Give me a big one. All right, Andrew. Zero minus 1,000. Negative though, right? Again, you have to think with this method. What's 200 minus 300? Thank you. 20 minus 50. 7 minus 6. Or again, I know you guys are like, I don't like this. Weird. Okay, then do it your way. It's fine. It's fine. That's fine. It's fine. It's fine. It's fine. 7 minus 6 is 1. Then we can't do. Then we borrow, and it's 12 minus 5, and that's like 7. Because if I go 5 plus 5 is 10, and then 2 more is. So that's 7, and then we have 1 minus 3. Oh crap! And I gotta. Oh. I can't borrow again, can I? Well, I guess it's negative, and like. You see what I'm saying? This method isn't very good for answers that are going to be negative. That's why they don't teach you this. And then when you get to middle school and they teach you about negative numbers, you're like, what the? Everything I know.
There are numbers less than 0?
It's not even that. I mean, that you can be okay with. Some kids figure that out ahead of time, right? Like debt, etc. You know. That's a good strategy. But you learn, this is what subtraction is. This is how you do it. There's no other way. This is what you do. And then it doesn't work. And you're like, okay now. Maybe I just suck at math. Now, Lily's correct. You can flip it and negate it. Why are you allowed to flip and negate? We know 5 minus 7 isn't the same thing as 7 minus 5. Exactly. We all do, right? We respect all kinds here. You prefer big on top. 1, 3, 5, 6. 2, 2, 7. If we subtract that, our answer is going to be positive. But wait a minute, we wanted the other version, so it's negative. There you go. It's negative answer. Keep going. 1,000 minus nothing, 1,000. 300 minus 200, 100. 550 minus 2, 50 minus 20 is 30. 6 minus 7. Oh no, 29 because it's negative 1, right? And it's negative because we wanted this one. That's it, man. That's it. We talked about how 5 minus 7 does not equal 7 minus 5, right? They're different. What about this? This is the same as. This is the same as. This is the same as. This. And one of these is a lot easier to do than the others. In my opinion. Probably the last two. Wait a minute, we're not allowed to rearrange. 5 minus 7 is not the same thing as 7 minus 5. That's correct. 5 minus 7 and 7 minus 5. You notice how the minus is the 7 here? And this one has the minus as the 5? Where's our minus? The 1. Where's our minus? With the 1. Where's our minus? With the 1. Oh. As long as you keep the signs with the numbers, you can do them in any order you want. That minus 1 isn't going to become a plus 1 just because we moved it around, right? This one's really nice, 24. This one's really nice, 24. The middle? What do you like about this one?
I can easily do
These two or these two? Oh, so 25. So you're doing like, well, the way you're doing it, if we write it out in order, is actually this one, isn't it? But yeah, it's the same. Yeah, exactly. And again, you can do subtraction in any order you want as long as you think of subtraction as addition. Wait, what? Really what's happening here is when I do 20 minus 1 plus 5 and I change it to this, is this is what's happening. I'm thinking of it like that. See how I kept the sign with the 1? And now it's addition, technically. I mean, no, addition you can move in any order. This is garbage, and they like show you this, like stop, please stop. And you're like, oh, negative times positive, negative, that's why it's the same. No, no, no. Keep the signs with the number. I'm gonna take 20 apples and then subtract 1 and add 5. That's the same as if I added 1 and then added 20. No, no, stop, no. It's still a -1. It's not gonna change anything. Just keep the signs with the numbers, you'll be fine. I want to show you something else interesting. A little bit about division. True or false? 3 groups of 4 plus 6 groups of 4 is the same thing as 9 groups of 4. And I grouped it like that just because I wanted to. You don't have these parentheses there. It's just to make it easier to read. True or false? Don't do math. Think logically. 3 groups of 4 plus 6 groups of 4 is the same thing as 9 groups of 4. Yeah, right? 3 groups of apples plus 6 groups of apples is the same thing as 9 groups of apples, right? We're all talking apples here. What about division? Let's do 100 divided by 4. Again, you don't need the parentheses, but it makes it nicer to read. Plus, let's do... By this logic, right? Groups of 4. Groups of 4. We added them to make 9. We added these to make 160. What do you think? What's 100 divided by 4? 25. 60 divided by 4. Clock. Cut it into quarters. Cut the clock into quarters. What do you get?
15.
15, right? 15 minutes is a quarter, right?
Oh.
The clock. Bye. We'll talk about this later. You guys have a good weekend too. Write about addition, multiplication, or subtraction. Your choice. I'm available until 3 today. 3:25. Kobe. Oh no. Alley-oop. 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 It's when somebody throws the ball at the hoop and then the other person grabs it and dunks it. Yeah. Woo! Is it 5th hour now? Oh man. That's a study hall. Alright, I'll be back, guys.